In our research group, we are working with scientists who often collaborate over large data sets. We've designed two interaction techniques to support this work on interactive tabletop surfaces. The first technique, the i-Loupe, consists of a two-part focus and context lens for overcoming three challenges that we encountered in developing applications for this domain: dealing with resolution discrepancies, supporting diverse interactions, and facilitating face-to-face collaboration. First, in order to overcome the resolution discrepancies among dense data, a medium resolution display, and relatively low resolution touch input, the i-Loupe provides flexible levels of magnification to reveal the fine-grained details of the visualized data. The level of magnification can be changed by resizing either the magnification region, or focus, or the area of interest widget, or base. i-Loupe provides both a higher resolution view of the data and a high-resolution portal through which scientists can interact directly with individual data items. One of the important design considerations in creating the i-Loupe was providing mechanisms for controlling the configuration of the lens while simultaneously preserving full interaction capabilities for a wide variety of information visualization techniques. In i-Loupe, we augmented the focus and base components' borders with touch-sensitive regions for manipulating their position, size, magnification, and orientation. In order to support data exploration at an even higher level of magnification than would be practical by manipulating the components' relative sizes, we also included a pair of buttons on the border of the focus for quickly doubling or halving the magnification level. With these controls, it is possible to achieve very high levels of magnification, 50 to 100 times larger than normal size, while still maintaining visibility of the surrounding context. The extremely high level of magnification provided by i-Loupe is not only useful for seeing fine-grained details in the visualization, it's also useful for applying general-purpose tools, like an annotation pencil, to regions in the data that would normally be far too small to interact with directly. In this way, i-Loupe takes on some characteristics of magic lenses, in addition to capabilities that have previously been associated more with passive distortion lenses. Our analysis of the design considerations for supporting information visualizations on the tabletop helped us to prioritize the interactions that our scientist colleagues use most often and design a technique that makes those interactions as accessible as possible. One of the important lessons that we learned while undertaking this research was how the nuanced design decisions and trade-offs in the tabletop domain do, in fact, significantly affect the overall user experience. By providing a mechanism for quickly reducing the magnification level, we inadvertently enabled the i-Loupe to mimic the world in miniature and radar view interaction techniques. Without the inclusion of the quick magnification buttons, this useful interaction would have been much more difficult to discover. We also designed an alternative version of the i-Loupe to run on an Apple iPod Touch handheld device. This technique, which we call iPodLoupe, is functionally equivalent to the tabletop-based i-Loupe technique, but illustrates how different design decisions can yield a substantially different user experience. iPodLoupe uses the multi-touch capabilities of the iPod device to combine control over the lens configuration, interaction with the visualization data, and use of auxiliary tools like the annotation pencil by using one or two fingers and gesturing directly on the magnified representation. Because the iPod is a tangible artifact, it is easy to rotate either the device or its base component on the tabletop to get a different perspective on the visualization data. This is a particularly useful capability when collaborating face-to-face with other scientists who may be standing on an opposite side of the tabletop display. Using the iPodLoupe feels very different from using the i-Loupe. Because the multi-touch interaction replicates the feeling of stretching a rubber sheet, interacting with the visualization objects on the iPod is similar to navigating in a zoomable user interface like Pad++, with an overview map shown on the tabletop to help prevent individuals from becoming lost on the infinite canvas. These techniques just demonstrate two possibilities when choosing from among different design considerations for supporting information visualization on interactive tabletop displays.